Hi, everyone. Thank you very much for joining the Science Abroad Switzerland information session today. I'm going to start the session with a land acknowledgement. We wish to acknowledge this land on which the University of Toronto operates. For thousands of years, it has been a traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this meeting place is still the home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. I will give you a brief introduction for the guests, and I'm Selena, Program Coordinator for the Science Abroad programs. I'm joined by Professor Richard and Professor Nicolina, who is going to supervise this program. They are currently in Switzerland, but they will give you very good details about the course. I also have a past participant, Isaac, join us today. He is going to share about his experience in Switzerland in the past summer. Later, I will speak about the EDIA resources we provided from our summer bar office and walk you through the application process. Then we'll open the floor for Q&A. And also just want to let you know that this session is going to be recorded, and we will post the session on website next week. What is Science Abroad? Science Abroad is a bit different from our regular summer abroad courses. Our regular summer abroad courses usually 4 weeks long, but for Science Abroad program, because you are going to do a research abroad, it is range from like 7 weeks to 12 weeks, depending on which program you are taking. It's a full year Science Abroad science credit. It's not a transfer credit. So you are going to use this credit towards your U of T degree. It's a great opportunity for students to use this experience to work in a research lab and also get supervised by the professors in the international institutions. So for a Science Abroad program, it's a very small group of students. We usually only accept a few students in each program because each students are going to be paired with a supervisor in the institution. You are going to work closely with the professors, and you also had the opportunity to work with the graduate students and students in the same lab. It's a great way to gain some international experience. Today, we will focus on the Switzerland program. So Switzerland program is a 12-week program happening in CERN. So you are going to do research in the European Organization for Nuclear Research. I would like to invite Professor Nicolina and Richard and to give you more details about this program.
Yes, so hi everybody. Richard and I were both based at CERN. We've been here, I've been here for the last 12 years or so, and Richard's been here for much longer than that. So CERN is the European Organization for Nuclear Research. So it's a giant 27-kilometer tunnel, about 100 to 175 meters underground. Goes a little bit under the Jura mountain just behind it, which is in France. It straddles the Swiss and the French border. And we collide protons most of the time, and for a smaller fraction of the time we also collide lead. Now there's 4 different experiments around the LHC. The one that we work on is ATLAS. It's a particle physics experiment. That's a sort of a general purpose detector. So we look for all sorts of exotic physics, or we try to verify what is known as the standard model, which is currently the most accurate description we have of how particles and forces interact. So the idea is that students work with us on analyzing data from the Large Hadron Collider, and we sometimes, one student works with, I guess, Richard or I. Sometimes both students work together at the beginning of the summer with one of us, and then later on with the other ones. And then we also have other PhD students and postdocs in the group that can work with you on these topics. So Geneva, it's the 2nd largest city in Switzerland, which for big city standards is not huge. I think it's a few 100,000 people. But it's very international, has a lot of international organizations here. We have the UN and many others. It's known for this jet that you see in the upper right-hand side, the jet. And accommodation is arranged off-site in an apartment. I actually missed this in the slides. Accommodation would be arranged. It might be on-site. We're not 100% sure yet.
Yeah, I will speak about the accommodation later.
And then we also have at CERN meals that can be purchased at the cafeteria that are cheaper than the typical prices that you find in Geneva. As I said, CERN straddles the border. So on the Swiss side, you have Geneva, and on the French side, you have smaller villages, Saint-Genis, which is the first one, which we haven't included pictures of, but it's also very charming. All right, so like I said, it's a massive tunnel, the LHC. This kind of shows it straddling both Switzerland and France. So you can see this dotted line here is the French-Swiss border. You can also see on the lower left-hand side is the airport in Geneva. This is a picture of the Atlas detector on the right-hand side here. So the way it works is for about 12 weeks in Geneva, you're working hopefully on some data analysis, and if time allows, maybe some hardware-like or commissioning-like work. But you'll probably be looking at analyzing data, maybe related to the Higgs, maybe related to some more exotic particles, and then you meet with us sort of regularly, and our students and our postdocs, and there's a longer write-up at about 10 to 15 pages of the work at the end of the summers. The topics we don't have outlined yet, but I think we'll have them outlined closer to the end of the summer. Okay, and these are so I mean we need to update these pictures, but we're rarely in the same place from the faculty based in Toronto and the faculty based at CERN. But this is basically the team. We have 7 professors on the upper left-hand side. You can see the professors that are usually based in Toronto. On the lower right-hand side is Richard and I, and another Professor Pierre, who I guess is in both pictures and goes back and forth quite frequently. That's just an introduction to the group. And then we have lots of postdocs and graduate students that you also have the opportunity to interact with while you're here.
Great. Thank you very much, Nicolina. So I quickly, as Lena mentioned about the accommodation, so I have an accommodation photo here so that we arranged a residence for students. So consider residence, but actually it's an off-site residence, so that you are going to stay in a studio. So the studio, so it's easable, very easy to go to CERN and by bike. So when you go to the program, you actually can rent a bike in CERN, but we need to reserve it for you in advance so that you can take it up, just riding a bike, because in summer, actually it's a very nice weather. So go in there in about 10-15 minutes. So in the studio, you will have an equipped kitchen and a microwave, refrigerator, and a bathroom. So quite nice. I would like to invite Richard to speak more about this course.
Sure. So hello, my name's Richard Teuscher. Welcome everyone. Actually, when I was coming to Toronto through Pearson Airport in September, the lost luggage agent asked what I worked on. And I said, oh, I'm coming from Switzerland. He said, oh, so you're a banker. I said, no, I'm not a banker. I'm doing research at CERN. And he said, oh, yeah, CERN. I've heard of the film Angels and Demons. So anyway, some of you may have already heard of CERN. As Nicolina already showed you, this is a picture where we work. So you don't see the ring as you fly in, but you do see the mountains if you're lucky on a clear day. You can also see the different experiments. So you've already heard about Atlas. So you can see a picture on the bottom right of the detector itself that goes along the Large Hadron Collider ring. And you can see the zoomed in circle is 2 graduate students for scale. And the countries that are involved you see in the upper left corner. So essentially all the continents are involved in some way on our experiment. And again, the team of people you can see listed there. So what do we do? Well, first of all, you may have heard about the Higgs boson. That was, of course, a discovery that led to a Nobel Prize in physics for the original theorists that presumed it to exist some half century ago. We've actually done this with just 10% of the data that we've collected so far. So there's a lot of data still ahead. We know its mass now and its width. So it is a well-established particle. This was not discovered when I started graduate studies at the U of T years ago. So it's something that shows we do discover new things. The other thing that the LHC has done is proven the success of what we call the standard model. So you see that on this coffee cup. That's another thing we do at CERN a lot. We like drinking coffee. So we wrote all of physics essentially in this equation. If you've seen Lagrangians, that's what it is. But it includes, if you've done electricity and magnetism, you can unify those into something called the electroweak theory. There's also the strong theory that holds the nucleus together. That's quantum chromodynamics. All that fits together into the standard model, but there's still questions. Why does it have this mass? 125 GeV. A GeV is a proton mass. What about the difference between matter and antimatter? It's another question. Dark energy you may have heard of, as well as dark matter. What about neutrino masses? Where do they come from? How does gravity fit into all of this? Because gravity is not in that equation. And finally, maybe there is new physics, as Nicolina already said, and that might be suppressed by some large energy scale lambda. So that's something that the LHC can look at. This is the sort of overall outline of where we are today. So the LHC has been running essentially since 2008 was the very first beginning, but then the real data was 2011 after an incident with the LHC when it took time to function. And these are all the different run periods, as you can see with time on the horizontal axis to today, 2024. We're entering now the winter shutdown because electricity is more expensive in the winter. Then this is actually going to be updated, but in 2026, we will also take data. So you would be here in 2025 when we're actually running the collider again in the summer and taking data. So that's where the students would come in. And then you can see there's a long-term plan. If you stay on in this field that goes past 2040, it actually is extended up to 2070 if you're really thinking of a career. And so today you can analyze the existing Run2 data set, as you've seen, that's been recorded. In the longer term, we're upgrading the experiment and collider into something called the high luminosity LHC. That'll be 10 times the amount of data. That's why I can say we're only at 10% of the data. And again, if you really have a career in the very long term, like 2045, there could be a future circular collider, which might be a new 100-kilometer tunnel. You can see what it might look like if it were built. Go on then, just to show a few more things. So this high luminosity upgrade that I talked about, that could be part of what you learn about. This is a simulation of what an event might look like in our detector. So actually the existing detector would die if we tried to run the high luminosity LHC with the existing Atlas detector. So we're building something called an upgrade. And in particular, one part we work on in Toronto and then assemble and put together in different parts of the world and then bring to CERN in the future is something called the Inner Tracker, which you may also hear about in the project. So that's a huge project. It will be essentially a camera taking pictures 40 million times a second, and the total area of the camera, it's wrapped in cylinders, but the total area is about 200 square meters. So it would cover all of your house if you have a big house. This is just some examples of parts that we're building. So these are actually being built in the clean room in Toronto. We have a special clean room in the basement there. We also have a partner in industry. You may have heard of the BlackBerry many years ago. This is the company that made it, Celestica. So they actually did the construction, not research in motion designing it, but the actual assembly of it. This is examples of wire bonding and building elements of this silicon microstrip tracker that you see here with the different silicon sensors. There's one little slice of this 200 square meters with the different readout chips, and then zooming in on the wire bonds and so on. So that's something we're building in Toronto. That could be part of your project, learning a bit in Toronto about it, and then continuing with a project here. All right, and we can go, I think we're almost on the last page. These are just examples of some of the people that have worked on the Atlas experiment with the University of Toronto group. So that was the introduction from my side.
Thank you very much, Richard. This is very helpful. Okay, now I would like to invite Isaac.
Sure. Hi, everyone. My name is Isaac, and I did this program this past summer from May to August. And I thought I would just talk about like the day-to-day life and what that was like. We got there in May, and then similar for my year, it was 2 students. For the work, we were working mostly with some of the postdocs in the group. It would be data analysis task where it took a lot of learning. We learned a lot of C and C++, and you're going to learn about Root, which is a programming language that used for a lot of certain computations. The tasks would be like we'd meet every week and get some instruction, and then we'd have our office in the photo in the very first slide, actually, where there's this cool projection on the wall of the CMS detector. So that's where we're working every day. One of the highlights of the program was in the month of July, because in addition to just like the 2 people going through the U of T program, there's a lot of other summer students who come to work at CERN. In July, they organize a lecture series. So each morning from around like 9 to 12, there's going to be 3 lectures given by like physicists or engineers talking about their research, and starting with like important concepts in particle physics or even astrophysics. And that was super, super fun. And how it ends up working, at least for that month, is that all the students, which is around 200-300, go to the lectures in the morning and then go get lunch together and then go work in the afternoon, which is just a really fun format. And then in terms of other aspects of outside of work, one of the great parts about this program too is that you're living in Geneva. especially because CERN is also only like around 25-minute tram ride from the Geneva Central train station. So there's lots of opportunities to travel all over France and Switzerland and even Italy, Germany, wherever you want to go, which is one of the other highlights of the program. It's a great chance to meet a lot of people. You get to learn a lot about what doing actual physics research is like. I know I certainly learned a lot about particle physics and also just improved my programming skills a lot. I hadn't had much experience with C or C++, and it was very useful and very fun. It was a great opportunity.
Thank you very much, Isaac. Now we go to the eligibility for applying to this course. This course is good for students who have strong interest in physical science, be comfortable working with advanced software. As one student asked about the C and C++, and it would be a benefit, but it's not required for this course. And also for at least a student need to have 8.5 credits and no more than 17 FCEs by the beginning of the program. So usually like by April 2025. And so what we are looking for is students in the second year and third year students. But if you do have like more than 17 FCEs or less than 8.5 credits, you can send us your credentials and also send us about your background if you're really interested in, and we will also consider as well. The minimum CGPA requirement is a 3.0. The application will be open on December 13, 2024. The deadline for this program is January 15 at 4 p.m. and students need to pay an application fee of $210. Later, I will give you a bit more information about this. So for when we assess your application, we will look at your academic record over the last 12 months, and we will see whether you meet the prerequisites and also the relevance of courses to your program of study. And in the application, we will also have the personal statement questions. And actually, we usually split it into 3 to 4 questions for you to answer. For science abroad students, you will have supplemental questions. Those questions are very important in your application. We would like to know like why you want to apply to this program, like how this program will help your academic study, and what about your academic plan. So we would like to know all those information about you. When you answer these questions, this is how you make your application strong. For 2025, we probably will add a video assessment as well. So for the video, and don't worry too much about this because it's going to be like online. So we will give you some questions and then you are going to answer. So usually it's only like 2 minutes to answer one question, a few video questions, but we will give you more information when our application is open. So admission decisions, we will make decision by early February. By early February, we'll make decision so that we will send out admission notification to all the students by early February or mid-February at latest. And an admission for this program is based on, I just talked about the admission criteria. And after you receive the admission notification, and you will have 1 week to confirm your participation in this program. And you will need to pay $1,000 deposit to secure your spot in this program. If you decide, okay, maybe you have other project you want to work on, and you decide not to participate in this program, we will offer your spot to another student on the waiting list. And the remaining fees for this program are going to due on March 12th. We'll confirm the remaining fees due date on the website later. Currently, we do not have the cost posted for this program, but all the information for this program will be updated by early December. So you should be able to see the cost chart in early December as well on our website. Please come back to our website to check the cost. You can be able to see the cost breakdown, like how much you need to pay to U of T, and how much you need to pay on your own. Okay, so usually for us, and we will arrange an accommodation for you and a course fee you need to pay to U of T. You are going to arrange your own flight to CERN and also the train, the travel as well. But we will give you more information about how to get there, and everything will be given to you in the post-acceptance section. For students who are going to this program, I would suggest you start budgeting now. You really need to know like when you need to pay out for the fees for the program. Check with your registrar's office and Faculty of Arts and Science and Department for possible awards and bursaries. Our Summer Abroad also offer awards as well. And the Summer Abroad awards application is embedded in the application. So when you're applying for Summer Abroad, and you are going to apply for awards application as well. So the deadline would be the same deadline when you submit your application. And also this course is U of T course. So it's also eligible for OSAP. If you're currently on OSAP, you can just apply for OSAP summer extension. But you please note that for the OSAP funds will not released until close to the start of the program. That means you will need to pay to U of T all the fees before you received OSAP funds. Students can also apply for CIE award. It's an International Experience Award offered by CIE, but you will need to go to their website to check criteria and also the eligibility criteria as well. We will also host How to Finance a Summer Abroad webinar on January 9th, and I would highly recommend you to register for that seminar so that you give you more idea of how to finance your summer abroad. If students who needs a visa, you will need to arrange your own visa appointment. And for international students, you also must check with the embassy or consulate to see if you need a visa to go to Switzerland. If possible, apply in Toronto, and I believe you will also need to go apply in Montreal as well. Check about the requirement, like a visa requirement to Switzerland. We will provide you supporting documents to show that you are currently taking this program. I believe CERN will also give you a letter to show that you are going to do a summer course like in CERN as well. So we will provide the documents as we can, but you will need to book appointment and also get visa appointment early. Okay, so if there's any additional documents you need, and we will try our best to support you. Some of our programs are committed to the EDIA. So we provide EDI resources for student communities. We really want to support students who have special needs and also can go to some abroad programs. For each location, and we have a site-specific EDIA resources. I would recommend you to go to our website to check it out. It's under the tab EDI and Accessibility tab, so that you can see the EDI resources offered by each country. Because for some countries, for the course in that country is very field trip heavy. So that means you may have a better position to take that course. Would it be good for you to really review all that and before you apply? For EDIA, and we have a program coordinator called Wen Zhe, and she is the program coordinator dedicated to diversity and inclusion in our summer abroad office. If you have the needs, and please contact her. I would highly suggest you to make a virtual appointment with her so that you can know like which location may be better for you, like for in your situation, and also like what kind of support we can give to you while you are abroad. So for students who require accommodations, you should register with your campus accessibility services office. So for UTSG students, you just register with the UTSG accessibility services office. But for the other campus and like UTM, UTSC, they all have separate accessibility service office. Please make sure that you register with them so that we can have a plan in advance. We will also request the letter of accommodation. You must be uploaded to the application within 7 days after being admitted to the summer abroad program. Our summer abroad office also offers Summer Abroad Inclusion, Diversity, and Excellence Award. You can go to our website to see the recipients in the past years. The awards availability is for 4 students and $5,000 each. I would highly recommend you to go to our website to check it out, to see the eligibility and also to see the recipients so that you can know more about this award. Here is a 2025 timeline. In November, for Science Abroad program, we all have the information sessions for Science Abroad. Yesterday, we also had a Science Abroad information for another course, like in Summer Abroad programs. In early December, we will get all the information, including the program details, course details, and the cost chart as well. So we'll be online. If you have any questions after you see the cost chart or any information that you would like to discuss more about it, you can always book an appointment with me. We can discuss about it. Our application is going to open on December 13th, and the deadline is January 15th at 4 p.m. I will highlight the January 15th, 4 p.m. at the deadline because our application are going to close the exact time. So make sure that you submit your application because we also have a video component. Submit a bit early. Okay, so that you also have time to do the video assessment as well. In late of January and February, we are going to send out admission notifications for Science Abroad, and we are planning to send out the admission notification in early February or mid-February. And then you will need to pay the remaining fees in March, and then you're going to Switzerland in May. We are quite active on Instagram. I would recommend you to go to our Instagram to check it out. For each site, we have a social media correspondent and who will record, or I would say they will do a summary of what they do like in that location. We also have a highlight week for Switzerland as well. So go to our Instagram, check out their experience in last summer and in the past summers. If you need more information, you can visit our website to get more information about the program. Also attend the information session. Thank you very much. And we also have an e-newsletter, which called The Summary. We'll be sending out to the students who created a profile on our website. You can always book an appointment with me or with any summer abroad advisor if you are interested in other summer abroad programs. We also have student ambassadors who are working on the Discord chart so that you can have that as well. You can go to Discord and to ask questions about summer abroad. We are here to support you before application, like during the application, and also after you got admitted to the program. That's for my end. If you have any further questions about the course, the first question probably still for Richard. Are we going to use Gym 4 for the program?
Those of you that don't know what Géant 4 is, first of all, in French,
Yeah.
it's giant, and it's a giant simulation program that, if you remember that picture that you saw of the events simulated in the high luminosity LHC version of Atlas, that's based on Géant. So it's particles passing through materials losing energy. That's what Géant is about. So the course that we're working on isn't directly simulating events in Géant, but you might end up using what are called Monte Carlo events that are generated with Géant. And then if you wanted to, if you had a very specific interest in that, I'm sure we could accommodate that in some way.
I have completed the physics study in high school, but I have never taken physics courses in university. May I apply to this course?
How do we best answer that? I was going to answer with sort of an anecdote. So two very good physicists started as one as an artist and the other as a journalist. So my general relativity prof when I was a student at Toronto began as an artist, Moffat, and then he later corresponded with Einstein after teaching himself physics. So it depends on your level of physics. If you have not done any courses and you have not taught yourself physics, then I'd encourage you to teach yourself physics and look, for example, at the lectures that are in the link to give you an idea of the level. I think it takes some time. We shouldn't discourage people from having a passion about physics, but you need some mathematics that goes a bit beyond high school. You need some programming, you need some concepts. So have a look at the material that's on those summer student lectures first. That's what I would suggest.
What is the rough acceptance rate for the program? It's hard to say. So because every year we have our application currently is not open yet. And also even it's open, we don't know like the number of students who are applying to this program. But for this program, you only accept 2 students. So actually this is a higher number than the past years. In the past year, most of the time we only accept 1 student. So actually it's a good year and for students who are applying to this program. But I just want to add that no matter like how many students are applying, and just make sure that you make your application strong. In the application, we have the questions for you to answer. So those questions are very important, something that you can work on and to make your application strong. We also later may have the video assessment as well. We would like to see students' adaptability and your academic background, your adaptability to another country. Can the professors share some examples of projects students have completed in the past?
Last year, it was searching for the Higgs boson, and Higgs decaying to ZZ events was part of the research project. Second half of the summer, they worked on trying to simulate events with what are called 4 jets, because we were trying to find a bit more exotic signals like quantum gravity searches. So the first half was a bit more of a standard model, a bit more than the first half, probably 2/3 were a bit more of a standard model oriented project. And then towards the end, students simulated and played around a little bit with simulations to try and get these 4 jet events to try and search for quantum gravity signals.
Again, there can be other things if you can get some time spent looking at the detector hardware as well. That could be a part as well. Maybe writing some programming for it, etc. But we try and give you exposure to both the data analysis, the physics, and a bit of detector work if possible.
Have there been any machine learning related projects in the past or any being planned for the future?
Certainly, machine learning is a part of the physics that we do as well. It can be ranging from the data analysis, trying to get a better, Higgs signal out, to eventually developing things for what's called the trigger. So how you actually select the events online. So I can't remember if there was one in this program in the past, but there certainly are people that work on machine learning among especially graduate students. So it's possible we could have you work with a graduate student or postdoc if that's a topic of interest. We can be flexible.
Okay, I didn't see more questions coming, so I'm going to end the session. Thank you everyone for joining this information session. I really appreciate Richard and Nicolina to be here to speak more about this program, especially from the academic side. And also thank you, Isaac, for sharing your experience in the program. And also thank you, my colleague, and Wendy, who is been monitoring the Q&A section for us, and also Lauren as well. Thanks everyone. And if you have further questions, please feel free to send an email to science.abroad@utoronto.ca. So if you have questions for the professor from the academic side, and we will also forward your question to the professors to answer. If you have any application questions, you can always contact us and to book a virtual appointment with us as well. Thanks, everyone. Bye.